Hello, everyone. Welcome back. In this part of today's lecture, we will discuss about the linked list. What is basically linked list and how it is different from the arrays. As you know about the arrays, array can become full. Means that allocating extra space in array can be wasteful and it can maybe never be used. So if we allocate the array with a very big size, then it can be wasteful. If we mm, allocate the array or initialize the array with a smaller size, so we can be run out of the memory. So size of array cannot be changed during the program execution. So we cannot change it. So data access speed becomes slow as size of array increases. So another um, important difference related to the array is that uh, if I initialize the array with the larger size, so data access speed is also affected. So on the other side, linked list only become full when the system runs out of memory. So it only becomes full when the system runs out of memory. Linked list can grow or shrink as needed. We can grow or shrink the linked list, increase or decrease the size of the linked list based on the requirement. So we don't need to define it beforehand, like in the case of array. Linked list can be maintained in sorted order. So it can be maintained in also in the sorted order. So insertion or removal of elements is easier. So we can insert or remove the element very easily. We don't need to move the elements to the next place to insert. Uh, Same like as in the case of arrays, we have to move all the elements to insert new element. But in case of linked list, it is very easy. Just we need to change the address of the node, so we can insert the new element. So similarly, removal of the element is very easier in case of the linked list. So various cells of the arrays are not allocated consecutively in memory. So as we know that in case of uh, arrays, the memory should be consecutive. So in case of the linked list, it is not necessary that complete chunk of memory is allocated at the same place. So existing elements do not need to be moved. So same like as I discussed already that if there are existing elements, so we don't need to move all the elements to insert or remove new element. So with arrays, the second element was right next to the first element. In the array, as we discussed that next second element is very next to the first element. But this is not in the case of linked list. You will see in the coming slide. Now, the first element must explicitly tell us where to look for the second element. In case of linked list, so first element will tell us where to look for the second element because it is storing the address of the next element. So in case of linked list. Do this by holding the memory address of the second element. As I mentioned that first element is holding the memory address of the second element or the next element. So how we can implement the linked list. So let's discuss. Create a structure called a node. As we know that linked lists are based on the nodes. So it can be a node can be defined by using this kind of structure. As you can see that is divided into two parts. Uh, First is the data and the other part is the we called it next. So data field will hold the actual list element. Our data will be stored in this part, or we can say the actual list element is stored in this part, and next field in the structure will hold the address of the next node. So it will hold the address of the next node. So as the name is referring that linked list means that they are linked with each other. So this is single node. It would be linked with the other node. Next node will be linked with the other node. This is how it would be working. So the chain of nodes together form the linked list. So this is the single node. So when I will make the chain, so it will make the data structure that is called linked list. So the chain of nodes is called the linked list. Like as it is shown here. So this is only showing the data. Here we are not discussing about the address. In the coming slide, I will give you the overview of the address as well. Basically, this is the head pointer or the pointer that carries the address of the first node. So you can say it head. So it is stored in the stack uh, kind of memory, and usually the linked list is in the heap memory. So this first pointer that is basically the head carries the address of the linked list or address of the first node in the linked list. So this is the picture of our list 26781. So this is the list stored as a linked list. So this is stored as a linked list and its size is equal to 5. Same like the size we are defining in the case of arrays. So here the size is 5 and current is pointing towards the current pointer uh, of the node. So this is how the linked list is defined. Note some features of the list. So it needs a head to point to the first node of the list. As we can see, it requires the head or the first pointer. Head is also sometimes set as a first pointer. Otherwise, we won't know where the start of the list is. So without this, I don't know where the start of the list is. So head is storing the address of the first node. Current here is a pointer, not an index. So this is basically a pointer, not an index. So it is telling where my uh, current node is. So current here is a pointer, not an index. The next field is the last node points to nothing. So the next field in the last node points to nothing. So and this is the last node and this is the data part and this is the next part. So the last node next is pointing to the nothing. So we usually call it null. So we will place the memory address null, which is guaranteed to be inaccessible. So we say that it is memory address null. We will assign to the last node, next of the last node. Okay, so linked lists are also said to be as self-referential structures. So self-referential structure, what do we mean? Let's discuss this thing also. As we know that data can be of any type, that is int, float, double, or character. Here in case of node, this data can be of any type. It can be integer type, float type, double type, or character type, or whatever. So next is the pointer. Pointer is of node own type. That's why we call them self-referential structure. So this is the data. It can be of any type, and the pointer. This is the pointer. This is the pointer. So pointer is of node own type. So it is of node's own type. That's why we call them self-referential. So it is a self-referential structure. Self-referential structure are useful in linked list. So this is very important uh, structure and very useful in the case of linked list. So and the uh, last node, it is basically terminated with the null pointer. So null pointer points to the nothing. So the last node carries the null pointer, or the we have said that uh, memory address with null. So terminated with the null pointer, last node. Okay, so if I talk how to write code in case of self-referential data structure, or in case of simple basic data structure for the self-referential structure, uh, this is how it is defined. So basically it is of struct node type, and in this structure we have integer data that can be of any type. As I already explained here, data can be of any type, and the pointer of its own type or the node type. As you can see, struct node, here struct node. So this is of its own type, pointer of own type. So it is next, pointer next. So this is we call data, and this we call next. So this is of its own type. Okay, let's take another pictorial view of the linked list. What do we mean by all the discussion that we have made up till now? So basically, this is our linked list. So here is the head that is pointing towards the first node. So let's see how it is working. So as in the head, there is the address for the first node. So head is carrying the address 1054. So 1054 is basically pointing towards the first data element, that is 2. Okay, so in the head carrying the address 1054. So 1054 is pointing towards the first data element, that is 2. Uh, so uh, the next for this 2 is 1054. This is data and this is next. So 1054 carries the address of the next node. So this is the next node. So 1054. Where is 105? Sorry, 1051. Where is 1051 in the memory? So these are the addresses, as you can see. So 1051, in the 1051, the element or the data 6 is stored, as you can see here. So uh, with the 6, there is the next. Here is the next, that is 1063. So this node contains the address of the next node one that is basically 1063. Where is 1063? Here is 1063. As you can see on this address, it is stored. So this is data and this is next. So it is 1054, as you can see, 1063, here 1063. So from here 1057 is pointing towards this node. So now it is 1060. Where is 1060? Here is 1060. So you can see I have pointed through this arrow. So this by this pictorial form, you can easily see the data as well as the next data structure pointing to the addresses of the linked list. So this is how the actual picture in the memory in case of linked list. As similar to the arrays, linked list operations we can also define. So the selected linked list operations are insert node at start, insert node at end, remove node from the start, remove node from the end, remove specific node, searching specific node, displaying all nodes. So these are the different operations that we can perform in case of linked list. So these are some of the selected linked list operations. Let's see how we can create a node by using different programming languages such as C language or the C++. So for creating a node, same as we have discussed already that it would be of struct node type pointer. We have taken P as a pointer variable. So as you have already seen in case of C language, uh, we use the malloc function for defining any memory location in the heap. So this is how the node is created by using C language. So struct node malloc size of struct node. This is how the node will be created by using C language. But in case of C++, it is very easier and simpler way to define the node. So P is equal to new node. So it is very simple. Most of the time we will be using this one. So let's see how it is defined. Uh, as you can see here, this is the pointer P that is basically pointing towards the first node, and the address of it carries the address of the first node, as you can see here. So for accessing members of the node, if I want to access the member of the node, here uh, I will say that P of data is equal to 10 and P of next is equal to 0. So as next is null or 0. So for accessing any member, if I want to access any member of this node, as you can see, this is the node. So P of data uh, will be 10 and P of next is equal to 0. This is how I can access the members of the node. The members of the node is data and next. So let's see some other important statements in case of nodes. So struct node, as we have defined two pointers, uh, variables such as P and Q. So here is the pointer variable p. Initially, its value is equal to 200, and q, we haven't assigned any value. Initially, you can say it is null. So, what would be the case if I say q equal to p? So, in this case, the value of p will be assigned to q. So, as you can see here, that as p was 200, so when I said q is equal to p, uh, now q is also 200. So as p was pointing to this memory location, uh, uh, or basically we can say this node with the address 200. So now q is also pointing towards this node with the address 200. So this is what this statement mean. Whenever I will say q equal to p means that now q is pointing to the same node that the p was pointing. Next, q is equal to p of next. So if I say that q is equal to p of next, so as p of next is this, yeah, as you can see here. So this next is uh, carrying the address of the next node, that is basically 210. So here in Q I have stored P of next, basically address, this address. We know that this is data and this is next. So I am saying P of next. So I am storing this address inside the Q. So now Q is pointing towards the. So these are a few of the important statements in case of nodes. So keep these in mind. This is another one. So P is equal to P of next. So if I say that P is equal to P of next, so P of next was 210 as we have seen here. So it is 210. So P is equal to P of next. Now P carries the address and pointing to the this node. So P now P carries P of next. Basically, this address will be stored in P. So this is how few of the statements we can define in the nodes. Okay, let's see very interesting example related to nodes. How I can insert at start of a node, or we can say the head of the node. So here I have two first pointer, and this is the linked list, and there is a new pointer with this linked list. So as you can see, this is our first pointer and this is the new pointer. So if I say that new pointer next pointer is equal to first pointer, so basically I am saying that this new pointer next pointer is equal to first pointer. So now the in the new pointer, the next will be pointing towards the first pointer, as you can see here. And similarly, if I say first pointer equal to new pointer, so if I say first pointer equal to new pointer, so this new pointer will be stored in the first pointer, and this first pointer would be pointing towards the this value. So this is how the we can insert at start or head of the pointer. So As you can see here, we have defined the first pointer, and this is our new pointer. And as you can see, we are basically assigning the next pointer in the new pointer. Here is the new pointer. In the new pointer, to the next pointer, I am assigning the value equal to first. So now it will be pointing towards the address of the first pointer. Here I have stored the address of the first pointer here. This is all for today. If you have any questions, feel free to send me through the email. Thank you. Take care and have a nice day.